Alright folks, day number 8. I will not be doing this proof on this video either. There will be a proof designated for the integrated factor. That'll be its own video. I'd like to do just a couple of the homework problems here, so let's get started. Alright, so solve the initial value problem given here. Okay, so I'm going to divide everything, all three terms, by 1 plus x. And what that'll give me is dy dx plus 1 over 1 plus x times y equal to 1. Right? If I divide 1 plus x by 1 plus x, I get 1. Alright, so that tells me that p of x is 1 over 1 plus x. Q of x is 1. Alright, so let's get into the integrated factor now. I of x will be e to the integral of 1 over 1 plus x dx. All of your superior integrating skills will tell you that that's e to the ln of 1 plus x. And therefore, our integrated factor is 1 plus x. Remember, e to the ln of anything is that anything. Alright, so now we're ready to do our setup. Q of x is 1, I of x is 1 plus x. So d dx of y times I of x is equal to I of x times Q of x. Well, we're going to get 1 plus x then. Alright, so let's integrate both sides with respect to x. So I get y times 1 plus x is equal to x plus x squared over 2 plus c. Alright, looks like initial condition up here is the point 1 comma 1/4. Alright, so let's plug them in. I get 1 over 4 times 1 plus 1, which is 2. Over here I get 1 plus 1 squared over 2 plus c. So 1/4 of 2 is 1/2. And 1 plus 1/2 is 1.5. So it looks like c is going to equal -1. Alright, so we go back. Let's look at our function. Where am I looking at? I'm looking right here. So y times 1 plus x is equal to x plus x squared over 2 plus, minus 1. Alright, so what I would probably do here, just to clean this up a tad, is I would multiply both sides by 2. And the reason I would do that, on the left, it makes it less simple, but on the right, it'll simplify it, and I'll get x squared plus 2x minus 2. And therefore, if I divide both sides by 2y, I get x squared plus 2x minus 2 over 2 times the quantity 1 plus x. Wouldn't that be great if the numerator factored out and had an x plus 1? That would be pleasant, but it doesn't. So there you go. There is our particular solution to that initial value problem. Let's do one more. Okay, this is in form for us, so it looks like to me p of x is x over 4 minus x squared, and q of x again is 1. So I of x is going to be e to the integral of x over 4 minus x squared. Alright, that is a U-Substitution Integration problem. I'm going to set u equal to 4 minus x squared. So du is equal to -2x dx. I see an x dx here, but I don't see a -2. So I'll go -1/2 du equals x dx. Alright, so I plug in. So I of x will equal e to the integral of negative 1/2, what is that, 1 over u du. So that would equal e to the power of negative 1/2 natural log of u. Alright, let's look at this for a second. Negative 1/2 natural log of u. U was 4 minus x squared. I see an arc sine coming, you might too. That would be the following, right? If I brought this negative 1/2 up as an exponent, what that would do is that would take and it'd flip it and it'd put it in a square root. Oh, look at that. Okay, so e to the natural log of that is just that. So it'd be 1 over the square root of 4 minus x squared. That's going to be I of x. There's our integrated factor. So now we got d dx, y times I of x. I of x is 1 over the square root of 4 minus x squared is equal to I of x times q of x. Q was 1, so it's just going to be I of x, 1 over 4 minus x squared, square root of that. Remember now, I see an arc sine coming on that right side here. Alright, so I integrate on both sides with respect to x. So I get y times 1 over the square root of 4 minus x squared is equal to, now remember this, over on the side over here, remember 1 over the square root of a squared minus x squared was equal to the arc sine of x over a. In this case, what is a? A equals 2. Therefore, I get is the arc sine of x over 2. Okay, plus c. What was our initial condition? 0, 1. So if our initial condition was 0, 1, I get 1. Okay, I'm plugging in a 1 for x, so that'd be square root of 4, which is 2. Arc sine. Oops, I'm sorry, I'm plugging in, 0 for x, so arc sine of 0 is 0. Okay, so this will be pretty easy. It'll just be 1/2 for c. So let's back it up. Oops. Alright, back it up here. So c is 1/2. Alright, so let's solve for y. Well, that would mean I just want to multiply both sides. So I would get arc sine of x over 2 plus 1/2 times the square root of 4 minus x squared. Pretty dirty function, but its derivative with an initial condition of 0, 1 can be represented in this way. Alright guys, that's it. Just a little extra practice there with integrated factor. Peace out. Hope it went well. See you.